In this section, we will learn again the ADT, abstract data type. This is about Q, and then we will check what is array-based Q and some operations about the Q. The QADT. The QADT stores arbitrary objects. You still remember what is arbitrary? Arbitrary means any objects. It can be numbers, it can be string, it can be Boolean, true or false. So the insertion and deletions follow the first in, first out scheme. If you still remember stack, what is stack? Stack follow the last in, first out. On the Q, it follows the first in, first out. Sometimes we call this is LIFO, and we call this is FIFO. Okay. First in, first out. It is the FIFO. So that's why we call it FIFO. And LIFO, it is LIFO. In this case, the operation insertion are at the rear of the queue, and the removals are at the front of the queue. So you can just imagine this is similar like the queue in the normal life, in daily life. Good. Second phenomenon. So the operation in the queue, there are two. The first is NQ. Means we want to insert an element at the end of the queue. And we can have object DQ, means we want to remove and return the element at the front of the queue. So you can see here NQ. I have the object 1, and then I want to NQ. So the object 2 will be inserted before or at the end of the queue, and then we have NQ3, and then we have NQ4, we have NQ5, we have NQ6. So the position will be 1, 2, 3, 4, 5, 6. Okay. And then if we want to DQ, then the number 1 will go out at the first. And then we have DQ again, the number 2 will go out. The number 3 DQ, then it will remove. DQ 4, it will be removed. And then 5, it will be removed. So the concept is different between stack and queue. There might be some auxiliary to operation. You know, auxiliary means addition. Additional. Okay, there is an additional queue operation. We want to know first. So first means I want to know what is the element at the front without removing it. And then I want to check the length. How many elements? How many elements now in the queue? And then Boolean is empty. I want to know whether no elements are found. There might be some exceptions. For example, attempting the execution of the queue or front in an empty queue. So if the queue is empty, but you want to know what is the front. When the empty queue is available, but you want to DQ, then it will be error. Okay, now let's see this one. I think this is similar with the stack. Okay? This is similar with the learning check when you did the learning check last week. Please pay attention on this symbol. This is the data, or we call how we save the data into the array. And this is the return value. So when you execute this operation, then you will get a return value. When it is empty, it means there is no return value. It only saves the data without showing. So that's why when you do the exam, okay, when you do the learning check, please be careful with this notation. When I give you the question like this one, so please write clearly with square bracket, for example, 5, because it indicates that when I do the NQ1, it means I will put the 5 into a list, or I will put 5 into an array. So if you don't put this symbol, it means we do not know what is this one, whether it is a written value or it is an array. So please make sure when you do the exam, you put similar like this one. Now, let's start with the empty queue. So empty queue means I have no elements in the queue. So queue first equals to empty. Now we have NQ5. Then the element 5 will be inserted. NQ3. So 3 will be inserted at the end of the array. I want to check the length of the queue. And because I know there are two elements, so the return value will be 2. Q dot dq. When we dq, it means we will remove the first value or the front. The front will be removed and we can see the return value 5, and now the array remains only 3. I want to check, is Q empty? The result is false because I still have one element. So I still have one element. Q dot dq. So I remove the element 3. Now Q becomes empty. Q is empty. Yes. This is because empty. Now if I want to execute this operation Q dot dq, this will be empty because there is no element in the queue. Q dot nq 7. So nothing happened here, but the array becomes 7. So we have one element 7 is inserted into the array. And then we have nq 9, then 9 is in the last of the array. We want to know what is the first. So what is the front of the array? Then the front is 7. So we can get the value 7. And the array still remain the same, 7, 9. NQ4. So we want to put a new element at the end of the array. Length Q. So we know that there are 3 elements. Then we will show Q dot dq. So we have 9 and 4 at the 7 will be shown in the return value. Some applications, in the waiting list. So if you go to restaurants, and then if you go to any kind of bureaucracy, Cookit Center, of course, you need to keep. So that's the real application. If you do with some kind of algorithms in your computer, maybe if you print, if you do the printer, if you put the documents into the printer, then it will be basically a cube. Page number 1, page number 2, page number 3, and so on. Or you can also do with the multi-programming. So if I run my program in this computer, it follows the rules, which program comes first, which program next, and so on. In the queue, it can be used for the direct application, indirect application. For example, we can do some auxiliary data structures for the algorithms, and it can be also used for the components, other data structures. When we use array in the queue, there is a way to optimize the array size. When we have an array, I think if you still remember, we learned about the growable array. You still remember? We have the growable array, incremental strategy. What is it? The incremental strategy, we want to add the element of the array by a certain constant number. If the constant equals to 1, then we will add the array every one element, every one element, every one element. Or we have the doubling strategy. What is it? We will double every time we want to add an element into the array. So we learned this one in the array section. But sometimes in the queue, we cannot expand the array. We cannot make the array growable because maybe the capacity, maybe because of the limitation. Let's say if you go to a restaurant, if the restaurant is only enough for 10 people, then you cannot have the queue more than 10 people. It means we need to have a kind of circular fashion. Circular fashion, what is it? We will have two variables to keep track of the front and rear. So this index of the front element and R index immediately pass the rear element. So this is the last index and R is +1. Array location R is kept empty. So R will be empty. So the pink color is Q with the elements. Now we can call this is a normal configuration. The normal configuration means the front and R is still in the position of in between 0 until n. Maybe this is n-1. Okay. But we can have the wrap around configuration. In the round configuration means the front is now here. There's Q here, Q, 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 and the Q is starting from the 0. So the R is here. So we call this is wrap around configuration. So because the Q size always fixed, so we cannot change, we cannot grow this array because this is fixed. Then after you reach this position, you need to use the index at the first part. So we got this is wrap around configuration. So in the queue operation, we have this kind of operation. We call it the modulo operators. I think you know the remainder of division. Let's say I want to know what is the current size of my queue. So the formula will be n minus f plus r modulo n. What does it mean? Now let's check this one. I have the front now. The front is 4. Okay, 0, 1, 2, 3, 4. Okay, the front is 4. And let's say this n is 17. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. And R is the position of the index R. So let's say the R is 1. Now I want to know what is the size of the queue. Size means how many elements now in the queue. So we can use this formula n minus f plus r modulus n. N is 17 minus f. F is the index of front plus 14. This is the index of R. That is 27. So this is 27. Modulus 27 modulus 17. So what is it? 27 modulus 17. Okay. 27 divided by 17. It is 1. And the remaining is 10. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the size is 10. What about this one? We have the F here. N is same 17, but now the F is 11. It is in the index 11. And the R is in the index 4. So what is the size of this cube? Size now you can follow with this formula. And it is 17. And then we know the F is at the position 11. So 17 minus 11 plus 4. 4 is the clear index. Then we have 10. 10 modulus 7. What is it? 10 divided 7. The result is 0. And the remainder is 10. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 10 elements in the queue. Or we can say we still have 10 people in the queue. Something like that. And we can do the queue operation. The queue operation, it means when we do the NQ means we want to add one element. We want to add one object. NQ throws an exception if the array is full. So if the size equals to n minus 1, then do the exception. But if it is not, then let's find the object. Where is the position that we want to put the new element? So Q in the position R will be inserted with the object O. And then R, the new R will become R plus 1 modulus N. What does it mean? So let's say again, we have this Q. So F is the position in the index 4, and then R is in the index 14. Now, the new R will be 14 plus 1, which is 15 modulus N. N is 17. Then, okay, the position is now, the new R will be index 15. What about this one? N 17, and then F is 14, and R is 4. So R will be R plus 1 mod N. 5 mod 17. Then the next R will be in the index 5. So why we need to use mod? It is usable when the R is in this position. When R is at the end of the index, so the next R will be 0. That's why we need to use the mod. And also with the Q. The Q means we want to remove a element. So if it is empty, then we will do the exception. If it is not empty, then let's remove the object in the F. Let's remove the object in the F. And then F will be the same, or now the new F will be F1, F plus 1 modulus N. So it is the same with the formula of R. So F will be going to the next one. So if we remove here this one, F will be going to this index. So in Python, I think I will explain this one after the mini exam. Okay, so after the E-class, I will explain this one using the code. Okay, so the code for the stack and the code for the queue. I will explain it after the mini exam. So this is the array queue. So we have the data, we have the size, and we have the from. If you still remember, we have the underbar. Underbar means underbar data. You still remember what is meant by underbar? It is to keep the data in private. Okay. Okay, so I will continue this code on Wednesday after the mid exam. Any questions? Okay, then thank you very much for attending class. Good luck with your exam on Wednesday. So,